before 2060. Now, CO2 emission reduction has become the key development strategy of China. There are three main technical measures to carbon reduction. The first is to improve energy efficiency technology. The second is carbon-free technology, which means to develop clean and renewable energy. I think everyone is very familiar, such as solar, wind, nuclear, and hydrogen. The third is the removal of CO2 technology, which is also the focus of today's report. We recover or capture CO2 from the CO2 emission power plant, a steel plant, and other such as the chemical plant, then transport by pipeline or other means, utilizing and storage at the terminal. At the terminal, we can to storage CO2 underground, or also we can for UR, for enhanced oil recovery, and so on. We call this technology CCUS, and it has developed rapidly in recent years. At the 2020, there are 65 CCUS facilities abroad, and 34 pilot and demonstration projects in the CCUS technology testing centers, and utilization for about 40 million tons per year. In China, there are 35 CCUS demonstration projects and only 6 commercial facilities, including coal chemical industry, power plant, and cement production, and other industries. The utilization and storage CO2 about 3 million tons per year. According to the China CO2 capture, utilization and storage annual report 2021, China CCUS pathway study report. In the next 20 years, China CCUS technology will mainly focus on the recovery and the utilization of CO2 emissions from coal-based fuels. After 2015, it will focus on the development of BECCS and the DCCS technologies. It means the CO2 recovery from the air. CCUS includes 4 technical links. It contains capture, transportation, utilization, and storage. And for capture, it includes absorption, membrane separation, and cryogenic. They mean the low temperature separation measured. Transportation includes trucks, pipelines, trains, and ships. Utilization includes chemical utilization, geological utilization, and biological utilization. And storage includes onshore storage and marine storage. This is the content of CCUS full process technology. And facing the major national demand for CO2 emission reduction, the key technology system of CO2 capture, transportation, and the resource utilization has been developed to meet the requirements of low energy consumption, high safety, and high recovery rate of the CCUS project. And the CCUS full process ground engineering technology has been formed and carried out. And also several cases, that means the projects have been carried out. The second part is the current state of the technology. For CO2 capture technology, it mainly includes solid adsorption method, solvent absorption method, membrane separation, and a low temperature rectification method. The CO2 capture of the flue gas after combustion, we call it post-combustion, mainly adopts the absorption method. Medium and high pressure medium concentration CO2 is more suitable for adsorption method and membrane separation method. High concentration CO2 gas source, such as coal such as the coal chemical tail gas, is more suitable for low temperature rectification. CO2 capture measures. In our discuss, focus on the chemical absorption. The chemical absorption process realize CO2 capture through the reversible reaction of CO2 and the chemical absorption liquid. The main point of the technology lies in energy consumption, absorbance, and equipment. Coal-fired flue gas CO2 capture technology has been developed around the difficulty of CO2 recovery. In view of flue gas low pressure, low concentration characteristics through levels small scale test, pilot scale test, and industrial test, we developed the new high efficiency, low energy consumption CO2 absorption solvent. This is the most important. The solvent must have the low energy consumption. Compared with an MEA, the absorption load of new increased by more than 33%, and the regeneration rate is increased by more than 20%. For UR, produced gas recovery and natural gas CO2 recovery, we developed different absorbents to recover CO2, including the activated MDA and improved Benfield absorption system. Absorbent, we have built several plants. We also perform carbon capture system energy flow analysis, focusing on heat recovery from lean liquid and regeneration gas. And from this picture, we can get the conclusion. That means the lean liquid have the most heat energy, and we must recover it. We developed energy saving technologies such as interstate cooling, Amira heat pump. For interstate cooling, we can to reduce the reaction heat between CO2 and absorbent. And for Amira heat pump, we recover heat from the lean liquid. and to reduce the steam to reduce the steam, and also we use the friction flow desorption and to recover the heat from regeneration gas. And also we coupling optimization were carried out to combine the several the energy saving process. For Songli power plant, we did several tests. The Songli power plant test show that the energy consumption or regeneration is as low as 2.3 gigajoules per ton CO2. Also the gigajoule per ton CO2, which is about 21% lower than the energy consumption before application. I think this is a very good result. The development of large-scale reactors at the level of 1 million tons is an important guarantee for the promotion of CCUS technology. Developed a large-scale CO2 capture reaction tower. It mainly focuses on the absorber. We based on the high mass transfer packing and the double wave-blade gas distributor and a compound through liquid and liquid distributor. Compared with the measured, the efficiency of the whole tower is increased by 20%. And we use this reactor technology in the Songli power plant 1 million tons per year CO2 capture project. The gas absorption reaction heat and the reaction kinetics test device is the key equipment for CO2 capture. It can measure CO2 reaction heat and absorption reaction rate, reaction order, and the mass transfer coefficient, and combine with the engineering applications. That means combine with the engineering design, such as the height of the tower. So technology integration, the process package design technology is formed, which contains the process plan, material balance, core equipment, and PID. The second is the pipeline transportation technology. According to the phase characteristics of CO2, the gas phase, liquid phase, dense phase, and the supercritical transportation modes were studied. And the CO2 pipeline transportation process design technology was developed, which can accurately carry out the process analysis of the large scale and long distance CO2 pipelines and determine pipeline process parameters. Through the evaluation of indicator parameters such as process feasibility, safety, and economic, the analysis of different pipeline transportation measures is carried out, such as the gas transport, liquid transport, and supercritical transport. The physical properties of the supercritical CO2 pipeline change very huge, and the hydraulic calculation model recommended by foreign countries. We find the model in the in USA. We compared with it. Then don't consider the change of CO2 density after environmental research. Calculate model based on the dense change is established, which solve the process design problem of CO2 pipeline. For venting safe, a safer critical CO2 venting technologies of multi-stage decompression and interstage heating was developed on the premise to ensure no dry ice generate. Field test of CO2 pipeline discharge, the CO2 phase change, jet expansion, heavy gas diffusion, dry ice sublimation, and other processes was studied. The influence run model of the pipeline leak and the diffusion were conducted, and the safety crack stop measured to stop the crack, such as the pipeline strength, impurity control. That means the impurity gas, such as others gas concentration, and installing crack stop ring were put forward. A CO2 cryogenic storage device and to compress CO2 device were developed. Multi-well metering technologies were developed to meet the requirements of accuracy and reduce the cost of metering. For UR production gas, we must to recover the CO2. If we capture CO2 in power plant, we inject CO2 for UR. Then the production gas have the CO2. If not recover it, the CO2 is not good because some CO2 because about 14 to 15% CO2 will emission to the gas. So several technologies were developed. Solvent absorption method for CO2 recovery or low concentration produced gas, and the absorption method for CO2 recovery or medium concentration produced gas, and also sometimes we use the membrane method. And the cryogenic separation method means a low temperature method for CO2 recovery or high concentration produced gas. The CO2 recovery purity is higher than 90%, and the CO2 recovery rate higher than 19%. Realize the recovery of produced gas CO2. For CO2 flooding storage monitoring technologies, we have had explored the time-sensitive environmental risk and early warning measures, and carried out the monitoring studies on soil gas, atmosphere, groundwater, ground deformation, and also the ground underground the remote sensing. We also developed CO2 capture and mineralization integration technologies, preparation of nano calcium carbonate by mineralization after CO2 capture, and mild condition. the carbon fixation rate about 200 about one. We can to fix CO2 in the solid waste. The purity of nano calcium carbonate higher than 97%, and whiteness higher than 95%. The third part is the typical cases. This is just some typical cases we discuss. One is sorry, the technical route of USA. Typical case is the Petnova project. This project capture flue gas CO2 from 240 megawatt generating unit and to 19% capture rate. Under the CO2 capture about 1.4 million tons per year. The capture CO2 is sent through 132 kilometer pipeline to the west farm field for UR. This project is currently the world's largest CO2 capture and enhanced oil recovery project for coal-fired power plants. And the investment is about 1 billion. The renewable energy consumption is about 2.1 gigajoule per ton CO2. This is a design value. This is a process of the whole technical route. From this picture, we can the technical route of the Petnova is very is not difference with typical the process, but it have some improve, such as the regeneration gas, heat recovery. We use the heat pump. I think it heat pump. The second is the technical route of Canada. This is the project we call it Banner Dam CO2 capture project. This project recovers CO2 from Badam power plant. It's about 1 million tons per year CO2 we recovered and then sent to Webin oil field for UR. The project started operation in December 2015. I'm sorry, 2014. The energy saving technology. The steam from the lean liquid, then use the compress to compress the steam. Then the steam after compress will get into the dissolver, and in the dissolver it mixed with the rich liquid. Then some and it will recover it. Some channel project I will introduce. The first is the demonstration project of flue gas in coal-fired plant in Sengli oil field. It's about 14,000 tons per year. And this project was put into operation in 2010 using the MEA technology, and it used EPC contraction mode. The CO2 in the flue gas of Sengli power plant is captured after capture, compress, dry, and liquid and store, and then transport to the Sengli oil field, the Qinglian oil field, by a tank truck for CO2 flooding and storage. The captured CO2 was transported to the Go-29 the demonstration area for oil displacement and storage, forming the whole chain, formed a whole chain of the project of CO2 capture, injection, reservoir, production, and produced gas recovery. This is the first CCUS demonstration project of flue gas capture, transportation, and oil displacement and storage in China and abroad. And I think this project, some reports know this project is also very famous. Next is the Yanchang 316,000 tons per year CCUS project. And this gas comes from the exhaust methanol exhaust tail gas. It is a very high concentration CO2 tail gas, and the CO2 in the tail gas is concentration in more than 19%. 19%. And the CO2 tail gas is directly transported after the compress, and then transport to the oil reservoir. And the transport distance is about 105 kilometers. Supercritical transport is adopted to carry out oil displacement and storage in Jingbian oil field and Qiaojiawan oil field. And at present, its injection station of the project is being put into operation. And this, you see this picture is Xingzituan oil field CO2 injection station. Next is the 20,000 tons per year flue gas from capture and purification project in Huarun Haifeng power plant. And this project put into operation in 2019. It contains two different measures test. We also call it the carbon capture test platform of China. It contains two measures. The first is the 15 tons per year CO2 chemical absorption measured, and 20 tons per day membrane separation measured. Next is the power plant 10,000 tons per year CO2 capture demonstration project. And this project lies in Jiangsu province of China. This project, the scale is small, but it built very beautiful. And also the product of the project is dry ice. This project put into operation in 2019. We also designed the biggest flue gas CO2 project. This is the Sengli power plant, 2 million tons per year CO2 capture and utilization project. In this project, I'm sorry, just wait a moment. Wait. 在哪呀？啊，你的这个实验室放底下柜子里吧。好，谢谢。 I'm sorry. In this project, low concentration CO2 or thermal power plant will be captured. Then remove some water and then compressed. Transport to Xianhe and Sengtuo block by pipeline. The total length of the pipeline is about 73 kilometers, and the design transport capacity is 2 million tons per year. Use the supercritical transportation. The feasibility study and the process package design of project has been completed. For me, I am responsible for the package design, the process package design, and do a lot of work in the project. Next is the Qilu petrochemical 1 million tons per year CO2 capture, transportation, and oil displacement project. This project, the waste gas also from the coal chemical until gas, and the CO2 concentration is about 91%. So for this tail gas, we first use the low temperature fraction method to capture CO2. Then we compress it, use the pipeline to transport the CO2 from Qilu, for petrochemical compression to Sengli oil field. This project is now have complete, and this is the first 1 million tons per year CO2 capture CCUS project in China. It has complete. The tail gas from the coal to gas plant, and the temperature is about 20%, and the pressure is about 3 kpg, and the flow is about 108 tons per hour. This the most characteristic of the exhaust gas is the CO2 concentration is very high. It's about 91%. And the operating flexibility is about 16 to 105%, and annual running time is about 700 hours. The process is pretty simple. The CO2 can be liquid by compress cooling and at any temperature between the triple point and the critical point, which is the base of industrial liquefaction of CO2. This is a technical process. This project adopts the process route of compressing, condensing, and purification to recover CO2. The raw gas of CO2 first enter the compress to have a very high pressure, about 10. Then the waste heat is recovered by the lithium bromide, heat pump, and then enter the drying hydrate and the liquefaction perfection system. Condensing and liquefaction to obtain liquid CO2 product under low temperature conditions. As your liquid CO2 product can stored in the storage tank area. The process is short in flow, low in energy consumption, and low in investment. and the low energy consumption compared with the flue gas. The flue gas, I think is about the foam about 13% is lower than the flue gas CO2 capture. The simple for this process, it's based on the fact that the CO2 and other gas have a different boiling point to separate. And the CO2 in the tower, in the bottom of tower, after is a liquid CO2, and some and other gases not liquid, in your gas dense than emit. The Chilu CO2 recycle project equipment mainly includes the compression unit, liquefaction unit, and the cooling unit, and lithium bromide cooled water unit, and a supporting tank form and loading facilities. The core equipment, that means the most important device is the purification system, the purification tower. Use the purification tower to ensure that the CO2 liquid product with a purity of 99%, and then pumped to the tanker area for storage. And also the core of the purification tower is the packing. For energy saving process, we have two energy saving technologies to recover heat from the system. First is the lithium bromide unit to recover the waste heat or the raw gas. That means from the tail gas. The waste heat from the final stage out of the CO2 raw gas compressor is used to produce low temperature water. The low temperature water further cools the compressed CO2 feed gas to centigrade and send it to the liquefaction and purification unit. This is the recovery heat from the raw gas. The second energy saving technology is to recover heat from the exhaust gas. In this project, the expansion generator set is used to recover the pressure energy of exhaust gas, and the generate electricity is integrated into the power grid in the plant. And depending on low temperature exhaust gas exchanges heat with the raw material gas. For this project, the total investment of the project is about 318 million RMB, and the operating cost of device is 119 RMB per ton CO2. The next very typical case is Xinhua 115,000 tons per year CO2 capture and storage demonstration project. This project, the operating flexibility is about 15% to 110%, and the annual working hours is about 1,000 hours. And the flue gas value is about 100,000 meter per hour. And the cover rate is higher than 90%. 90. Product gas purity is higher than 99.5. Operating life is about 20 years. The flue gas comes from the outlet flow of the Shijian power plant after the diesel after the SO2 is removed. And the flue gas CO2 concentration is about 11.1% after CO2 capture, compression, drying, liquefaction, and storage in power plant. CO2 with a purity of 99.5% is emitted and then transported to the storage site. For this project, the device includes 5 units: capture, compression, drying, liquefaction, storage, and loading, and then transport by truck. This process is very similar with the Sengli power plant CO2 capture power plant. The energy saving process, it contains 3. The energy saving process to recover lean liquid heat and to remove the reaction heat. The first is the MR heat pump, and the second is the staged steam regeneration to recover heat from the regeneration gas. And the third saving process in the interstage cooling to remove reaction heat. This is technical indicators and the steam we used for CO2 regeneration for liquid regeneration is about 1.27 tons per ton CO2. And the area of this project is about 76, about 5,000 square meter. For this project, the area, I think it's very small, so it's not very beautiful because we have a very small area. We cannot find other area to contract. We generate 415 tons CO2 per day, and so we calculate and we how to inject the 415 tons CO2 of this project. And the Xinhua group of Jinjiang power plant have a conference with the Yanchang oil field, and we discussed it. About 300 tons of CO2 per day can transport to the Xinjiang oil field, and use the truck to transport the liquid CO2, and others and 114,700 CO2 use the truck to transport to Jinjiang oil field. This is also the Jinjiang oil field and the Xinjiang oil field. They all belong to the Yanchang oil field. For the project, on the condition that the internal rate of return after the full investment reaches 8%, the CO2 sealed expense is determined. When the internal rate of return is about 8%, without considering the transportation cost of the tank, the CO2 sealed price is about 216 RMB per ton CO2. When the internal rate return in 8%, we considering the transportation cost of the tank, the CO2 sales price is about 325 RMB per ton CO2. The next capital case is the China Resources Power. We also call it a Huarun Power Plant. 1 million tons per year CO2 capture, transmission, and storage demonstration project. Capture, compress, and liquid the flue gas generated by the Unit 1 of Haifeng Power Plant. Then it transport line and shipped to the CCUS storage site to bury it in soil water. And also some of the CO2 is for UR. The design, the capture, and the storage capacity is 1 million tons per year, and it is transported by the dense-free ships. For this project, we have finished the feasibility study. Next is the Ningbo Steel 20,000 tons per year CCUS capture and application project. This is relying on Ningbo steel cement, adopting advanced chemical absorption process, mineralization process to build 20,000 tons CO2 per year capture system, 10,000 tons per year CO2 mineralization project, and 10,000 tons per year CO2 dry ice project, and optimized post combustion CO2 capture, mineralization fixation whole process system. Now this project is finished the feasibility study. And this case, we have a prize. The champion on the China division. The next case is 215,000 tons per year CCUS capture and application project. This project taking Beiyuan Chemicals Safe Provided Power Plant as a research object, adopting advanced chemical absorption process and mineralization tons per year CO2 mineralization project, and 100 tons per year CO2 liquid project, and 15,000 project. The next project is the Fosun Jialida 10,000 tons per year CO2 capture and the resource utilization demonstration project. This project is the first CCUS in plating industrial of China, and it is also the first demonstration project of in Guangdong, in Guangdong, Hong Kong, and Greater Bay Area. This project builds 10,000 tons per year flue gas CO2. 18,000 tons per year. The CO2 fixing project, and 5,000 tons per year CO2 liquid project, and about 1,115 tons per year dry ice project. This project is now have finished the feasibility study and the package design. And now about this I'm sorry, this month have the build start conference in the Jialidang conference. This project is scheduled to basically complete put into operation by the end of this year. I think it will finish in time. Okay, that's all. Thank you.
Great, that's very informative and then presentation, and then lots of great information, summarized lots of case studies, and then thank you so much, and then Shijian for the great presentation. And then we open for questions, and then Dr. Wilson.
Dr. Liu, thanks very much. Very impressive. I'm very impressed with what's going on in China, and certainly your role in all of this. I'm curious as to why you want to transport the CO2 in pipelines in a supercritical state as opposed to a liquid state, and what kind of temperature is the CO2 coming out of those heating units. The CO2 from North Dakota coming to Saskatchewan to Weyburn is transported as in a liquid state as opposed to a supercritical state, and that's 325 kilometers of pipeline. Thank you.
Shijian, did you get the question?
Yes. 张老师，我直接说汉语了，因为那个其实刚才没有听特别清。
Yeah， 就是你这个相当于是transportation 啊，做二氧化碳那个运输的时候，你为什么要在超临界状态下运输呢？因为我们这边一般都是在液态下进行运输的。
哦，这我直接用汉语比较专业，我简单回答一下那个张老师，你给他答复一下。
好嘞。
这样的，其实我们的运输有多种形式。我们液态的话，一般现在这种小规模短距离的一般是超车运输。像规模比较大的，达到50万吨、100万吨级的，我们都是采用管道了。管道的话，当然管道的话也得看距离、看形式。比如说举个例子，我们这个齐鲁这个项目，齐鲁石化这个100万吨的项目，它经过淄博、经过东营这种人口特别密集的地方我们考虑采用当时专门论证过超临界还有气象哪种更合适，因为考虑到人口的密集的程度最后采用的是气象。超临界的话，我们认为是更适合这种长距离大数量的，那距离更长，长距离你像那个延长的项目100多。
但是你那个超临界你那个温度怎么保证呢？
这个温度是，其实现在这个是有争议的。都超临界的话，我们就像美国的一样，这是起诉的起始的时候，起诉的时候是超临界，起诉了超临界，然后经过一段时间以后，它从超临界都转变成为密相，这种情况，对，因为像美国的，我们去调研过，美国的管道它很多都是在地面以上的。那也都起诉的时候，超临界很快的温度都降到那个室温嘛，降到大气温度。
对。
我们国内的这种管道啊，包括天然气管道，那都是埋地的，一般都冻层以下。埋地了以后，经过一定距离以后，温度也会降到这个地下的土壤温度是完全相同的温度也会降成地温，我们叫地温。降到地温的话，的温度一定是比这个31度是要低的，所以它是从超临界这种状态逐渐转变成这种高压的密相状态。它这样的。
Yeah. So and then to answer Dr. Wilson's question, and then actually, and then in the outlet, and then the temperature might be higher than 31, and therefore it's super critical. And then because in most cases the pipeline still buried under the ground, And then, so the underground soil temperature generally is lower than 31. So actually during this transportation process, and then it might be goes to the liquid phase. And then in some area, and then because the pipeline is going to go through the area in the city, and then there's lots of population. So in those cases, and then for the safety, they trying to keep the CO2 phase in the gas phase.
Okay, thank you.
Yeah. So any other questions? And then you can type your question or you can raise your hand.实践你们这个齐鲁石化这个项目现在已经在那个相当于是开始动工了吗？
齐鲁石化这个项目刚刚说已经完成中交了，完成中交，中交的是工艺部分已经完成施工完毕，就前端的话，它不是这种高浓度二氧化碳一个提纯嘛，液化提纯，它这块已经建设完成了。
Okay, so my question is, and then the Qilu and then petrochemical project, and then where is that status? And then the construction is almost done. So and then the 那个胜利电厂那个项目的话，现在是已经相当于是开始建设了，还是在做前期方案阶段？
目前处于科研阶段，还在论证科研。
还在科研阶段 ，feasibility study。
Yes, 对 ，Yes.
So the power plant, Sunny power plant, and then still under the feasibility study stage, and then still not constructing yet. 那个项目的那个相当于是时间节点的话，他们是准备什么时候开始？相当于是完成方案认证，然后什么时候开建呢？
预计吧，只能预计，他现在没有明确的时间点。预计的话，今年会开建。应该是今年，我之前也这个项目后面可能我也会参与，应该是今年完成，上半年吧完成的科研的一个论证，下半年应该是今年主要是做设计为主，我预计今年会开工，应该会开工。一般是你设计做完初步设计，咱们国外叫基础设计 basic design 嘛，国外叫 basic design，一般做完这个 basic design 以后，就土建都开始动工了，应该今年土建会动工。
The Sunny power plant project, and then they may complete the engineering design this year, and may start and then to put up the construction by the end of this year. That's the original plan for this project. So that power plant, and then like, did you get the concentration of the flue gas, and then is there impurity, and then what kind of aiming systems you are going to use? 你们的那个类似像安法那个相当于是做吸附来。
对，用了生电厂这个用了安法。
你们的安永液什么的那个哪个地方的安永液？
安永液没有定，其实它一定是二点溶剂，就是复合胺的吸收体系。
复合胺。但是你那个相当于是因为 Boundary Dam 那个相当于是项目里面发现，就是说最大的一个经验就是那个溶剂的话选择是非常重要的，因为那个如果是你的那个气里面有一些 impurity， and then that's
impurity 对。
Yeah, and that might affect the recovery of your amine.
这个溶剂选择一个是它的降解性能，就是你要稳定；另外一个是溶剂的一个逃逸，那逃逸会从吸收塔顶逃逸，这个很关键，因为那个边坝那个项目就是氨逃逸好像挺严重的。
Yeah, that's right. So, any other questions from the audience?
Hi, Dr. Zhen. I have a question from the WeChat platform, and I will translate by myself, and I will ask these questions to Dr. Lu and in Chinese. 陆教授，就是我们这边公众号上面的有一个问题，就是想请问您，一般的项目运营周期，像我们的 CCUS 项目运营周期大概是多久？然后牵涉到的就是大概的运营成本，能不能给出一个估算，或者说我们考虑一个综合成本的那个提供一下，大概的综合成本的这个价位，因为有的人对这个比较关心，谢谢。
您说这个运营周期应该指的是这个工程的一个寿命吧？
对，
工程寿命一般现在很多设计是20年，工程寿命一般是20年。但是部分设备的寿命，就你的工程里面会用到一些设备，部分的设备寿命可能是15年，是这样的。这是我们从工程来说还是20年。你对于这个运营成本的话，其实这不好说，得看你用的什么工艺。刚才介绍的时候，4种工艺，它那个对应的气源不一样，它的成本变化很大。你像对于这个烟道器二氧化碳补给，那化学吸收法的话，它的成本的话，目前一个运行成本的话，应该在200到300之间这样一个范围。
Okay, and I will translate into English. My question is, what's a usual CCUS project operation duration and the capitalism cost? And Dr. Lu just said that the whole process of an CCUS project will last over 20 years, but it just depends on the duration of our equipment. The usual equipment used for CCUS project will last about 15 years. And the capitalism for the CCUS project, the carbon dioxide price for this project is about over 200 China yuan. It's if we exchange to the Canadian dollars, it's about 45 or 50. Yeah, that's all for my questions. And another question I want to talk to Dr. Lu is that in Chinese, or let's talk in Chinese first. 我们微信平台还有一个问题，就是想请问陆教授，二氧化碳压裂在国外的 CCUS 中应用规模如何？请问您对此有做过了解吗？或者说您能否给我们提供一些相关信息？谢谢。
二氧化碳压裂在国外，因为我是做那个地面工程的，所以对于这个压裂这一块并不是特别熟，就尤其是二氧化碳压裂这一块。我了解到的国内二氧化碳压裂一个中石化也是有做过一些前期研究，更多的是一些实验，还有延长石油也做过现场实验。没有规模化，国内的话应该是没有特别规模化的一个应用二氧化碳压裂这一块。好的，
谢谢。And I will translate into English. Here we got questions from our WeChat platform, and to see whether Dr. Lu have some information to provide for the CO2 fracturing in our other countries beside China. And he just told us that he may be not very familiar with that. But in China, the Sinopec group and Yanchang Petroleum Group, they do have some small pilot tests for the CO2 fracturing. And that's all for my questions. Yes, and the third question here is, and let's talk in Chinese first. 陆教授，这边最后一个问题想问您。就是二氧化碳未来碳封存的项目对于这个二氧化碳的成本未来有多少的价格的下降空间或者优化目标？谢谢。
你说是碳封存吧，还是碳捕集？碳封存。
碳捕集。
碳捕集是吧？碳捕集的成本下降空间应该还是有较大的下降空间的。咱能从这个再生能耗energy consumption 这个角度来考虑。目前的一个能耗值大约是2点几啊，那国内外都差不多，大约是在2.5个 G 上下左右，2.5到3.0 G 这样一个能耗值。我们这一代的技术，包括我们也正在做研发，我们课题组在做研发，这个能耗值一定是下降到2.0以下的。我预计未来的应该是在能耗值下降的水平应该在1.5到2.0之间，应该说在比目前的情况下应该能再下降1个 G。下降1个 G， 这个应该在成本反馈上还是下降很多的，至少能下降，我认为应该能下降50-60块钱，甚至更多。这个是已经很大的一个下降空间了。
Okay, and I will translate into English. They want to know, the question is about how much potential the CO2 carbon capture capitalism cost. Professor Lu just told me that at present, the energy consumption index is about 2.7 to 3.0, and their target is about lowering the energy consumption index less than 2.0. And they, if it is exchanged to the budget cost, it will lowering the CO2 capture cost from over 200 to about 180, 170 to 180 China yuan. Is about 35 Canadian dollars. Yeah, that's all for my questions here. Thank you, Dr. Lu. 谢谢陆教授，这边是我这边的所有的问题。
Okay, you're
Right.
welcome.
Yeah, and then any questions from the Zoom? And then I didn't see any hands. And then I didn't see anything from the chart. Any further questions?
Sorry, Dr. Zhen.
Yeah.
There are a few more questions from our WeChat platform because a lot of our audience are from China. They just are typing in Chinese, and I will translate that to Dr. Lu and for the translation to Dr. Malcolm Wilson and other audience, our international audience here. 陆教授您好，这边还有一个问题就是，超临界二氧化碳管道的试运投产过程中如何控制它的相变？
控制这个相变，只能就是应该说是，我们是目前是不控制的，是不控制，这个是不控制的，因为这个，但是你也不能，他的怎么说？刚才其实已经就是曾教授这块已经问过了，这个他都是你像咱美国的，举个例子，像美国的二氧化碳管道都是在地面以上的，不做任何的那种保温或者其他的一个措施，也不是不做保温措施的。我们国内的话都是这个管道都是埋地的，在冻层以下。但是这个埋地以后，它的运行一段距离以后，温度就变成低温。我们这个二氧化碳管道更多的是控制的是安全，还是控制的安全？目前的措施都是控制安全的，比如说二氧化碳发生泄漏以后，怎样能快速的，它建的阀室要设置的比天然气的那阀室一定是要密集的，一旦发生泄漏以后，压力下降，包括一些地下的光纤的这种监测、泄漏监测。还有一些其他的感温、感声、感震啊，各种监测手段，一旦测出来以后，这两个阀室泄露的两个阀室之间快速的截断啊，这样的话可以减少一个二氧化碳的一个释放量啊，这样的一个更多的是安全的控制。对于你刚刚说相态的控制，我们一般起诉是超临界的一个超临界态，然后起诉超临界态，你说起诉有专家问起诉用不用密相行不行？也可以，你这温度降下来，它都变成密相了，也是没问题的。但是我们从经济型的角度来考虑，是没有必要的，因为你往下降温也是需要能量的，也是需要耗能的，那只是这样的一个过程。当然说你这个什么时候控制它的相态啊？我们更多认为是在油田内部技术，比如说我油田内部现在更多是注入泵往地下注二氧化碳。这种形式更多，因为为了入泵之前是液态，我们的二氧化碳到达末端以后啊，比如说我们的用超车也好，用管道也好，卸出来以后，保证油田内部的这二氧化碳集束管道它是液态的这种状况，一般是要做保冷的，我防止它气化，防止里面因为温度升高产生那种气体，对我们的注入不利啊，这样一种情况。当然的话，你如果是我刚才说的这是超临界。如果你是气象的话，如果你气象二氧化碳输送的话，更多要控制它的压力。能看那个相图都能看到，它的压力一定要小心，防止这个压力应该是控制压力在一个合适的这个区间范围之内，是这样的。因为它温度压力不宜太高，也不宜太低，是这样的。
好的，谢谢陆教授。And I will translate into English for this one. and they just want to know, the question is about how to control the phase change of our carbon dioxide during our long time or long distance transportation in our CCUS project. Dr. Lu just told us that they will not control the phase change between during our transportation. Instead, the transportation, who should it is the oil companies who wants to inject CO2 underground into their oil reservoirs. They have to control the phase change based on the CO2 phase diagram for the field transportation in our CCUS project. And that's a brief answer for these questions. Thank you.
So is there any other questions from the WeChat?
And I think that's all for all questions from our WeChat platform.
The WeChat platform. Okay,
Yeah.
I didn't say anything from the chart, and then I don't have any hands here. And then I think that's conclude and then this session, and then I will back to Dr. Wilson for closing remark.
Well, Dr. Lu, thank you very much for the presentation. I'm certainly impressed with the work that's going on in China, and certainly your goals of bringing down the energy efficiency or improving the energy efficiency of CO2 capture. That's certainly the, as we call it, the holy grail of CO2 capture, and particularly using chemical systems. If we had more time, we could talk more about some of the other technologies that you're looking at, and particularly things like the mixed physical chemical solvents to capture the CO2 and so on. That's all very interesting. So I would like to thank you very much for the presentation, for the time you've taken, and for the great deal of interest that you've raised. Thank you.
好，是这样，非常感谢你这次给大家的那个精彩报告，你这边做了非常多的工作，然后来希望以后我们进一步交流二氧化碳普及方面的一些技术，好吧？
客气了，OK, you're welcome.
Okay, so that's conclude tonight's session, and then thank you very much. And then our next talk is going to be next week, and then the same time as today. And then our next talk is going to move from the surface technology to the underground again. And then it's from Dr. James Sen from Texas Tech University, and the Fulbright professor at the University of Regina. So that's next week's talk. So, and then have a great rest of the day, everyone. And then this completes our today's talk. See you, Dr. Wilson.